Hi guys, it's me UBprogrammer, and in this video I'll be talking about 20 machine learning and deep learning projects. Some are from machine learning, some are from deep learning. Let's get started. Hi guys, it's me UBprogrammer, and in this video I'll be talking about a deep learning project which is also called ANPR, or Automatic Number Plate Recognition System. The project is really cool. It recognize or detect the vehicle number plate, right, and it tells you the number extracted from the number plate automatically, right? And I want you to know, if you are enrolled in any master or bachelor program, you can contact me on this WhatsApp or maybe this mail to discuss about your coursework or projects you are working on. Okay, let's get started with the project. So this is the simple UI of the project, and you can see we got the heading as automatic number plate recognition app, and this is built by the Flask, right, with the Python. And you can see the description. So we have to upload an image of the number plate of the vehicle, and this app will tell you the license number plate with the help of deep learning model. And the model we are using is YOLO, but let's just start our app and give you a demo. So this is the example input, or some starting input to check our app, and you can see the number plate we got is shown here. And this is the UI built by the JavaScript, right? So we have used some JavaScript here, and you can see the description is the same. And you got this button, so this original image, and this was your input, and this is the image produced by our model or our app, right? And let's see if our model predicted it right. So yeah, it's LR33TEE. So yeah, it recognize and detect the number plate 100% correct, right? But I have to tell you that it will not be the case with every picture or the every vehicle, because there are so many factors, right? Lightning factor, or maybe the vehicle number plate isn't that clear to the model, or the writing style isn't perfect. So there can be so many factors, but the accuracy we are getting is quite great, and you can see the results, right? Now let's give it some other input. Now let's give it this one. So this is quite a big number, and you can see we got 21 BH, and if I just zoom in a bit, so 21 BH2345, and yeah, so you can see it just excluded the double A. So that's what I was talking about, because the data on which we have trained was considering or having the number plates with only this kind of length, right? But the accuracy is good. You can just train it on your custom data set and get the results as required, right? And now let's see the app. So this is the full project files, and let's open it in the VS Code, Microsoft VS Code. And yeah, let me just show you how you can build this. Okay, so this is the app.py, which is the main file, and if I can show you, so we are running or executing this file with the help of Python app.py here, right? And I'm using the Anaconda and a dedicated environment for this ANPR with the Python 3.7, because it has torch and other packages which can be or you can say which are stable on this 3.7 version. And as you know, the 3.11 is here, but the torch, PyTorch or packages like that can be you can say break by that version, by the new version, because these are not stable right now, right? So it's better to use this 3.7 with the Anaconda. You can always contact me for this Anaconda confusion if you want. And so the model we are using here is the YOLO v5. So it is you only look once, and the version is 5, and we are deploying it custom on the custom data and in our local machine, right? So that was the approach, and you can see we are using the model which is YOLO v5 master, and it is custom dataset, and the source is the local machine, and this path is the weight file which is here, best.pt. pt is the extension for the weight file for the YOLO, and this is the weight file we have get from this notebook when, if I just show you, when we have executed in the Google Colab, right? Because you can guess that this YOLO v5 is quite an huge model, so it will require some computation. So Google Colab can just give you the GPU power, so I have used that, and you can see this file, this last.pt was the our best file, right? And I have used some other techniques to make this better, and that's why I was calling it best.pt. And so this was executed on the Colab, but I'm showing you here in the VS Code, because we have get the this weight file, and that's what we wanted. And the these path is the requirement or the syntax requirement for using the YOLO v5 on your custom data. Okay, and let's see the templates we are using, right? So in the index you got this heading, you have seen this in the app, and some description, and you have the submit button where we will give the file or the JPG input file of the vehicle number plate. And then in the display, what we are doing is we are getting this file and processing it in the app.py, and then we have two files, which is the original image, and then the other file is the output of our model, the output image. And by using the on-click functionality of the JavaScript, we are changing or using the toggle of these buttons, right? Okay, and this is the JavaScript which we are using. Okay, and this whole source code you can get from the description. There will be a link about it, so you can easily download it from there, right? Okay, and let's see what we have missed. So this static and template, I hope you know about it. It's from the Flask. And let's see the packages we have used in this project. So PyTorch, NumPy, Pandas, these are the basic packages, and Jupyter we have using it. EasyOCR to extract the text from the number plate, So these are the packages, and you can just install it from these commands, right? And I have made this versions, or you can say the requirement.txt, which you can easily install it with the Python, right? So this will give you exact versions of all the packages you need to run this project. And there are these instructions. When you download this project, you will get this instruction file, instructions to run project, and you will get all these methods. So there are 3 methods I have written in this file, and you can just follow any of this and run this project on your local machine. Or I have said, in case you are unable to run the project, you can always contact me on this WhatsApp or email, right? So I will just maybe take care of that, right, with the Zoom call. Okay, and you will get all these files with the in a zip file from the description, and you can download it from there. So I hope you like the project, and this was it for this video, and I will meet you in another video with some amazing project. Thanks for watching.
Hi guys, it's me UBprogrammer, and today I want to discuss about a project which is of deep learning object detection. So let's just run our app and see what it looks like. So we go to our Flash server, let's follow the link, and it's asking for a image, right? And as the project description says, upload an image, and this website will try to predict what object the image contains, right? With the help of obviously deep learning YOLO algorithm and framework and OpenCV, right? And let's just give it some input of this image and see what it can give us. Okay, so it's showing us the output, and thanks for using our app. Let's just zoom in a bit and see what we got in our result, right? And you can see we have a person, annotation, and dog. So it has like successfully detected objects and make the bounding boxes, but the dog, you can see it's not clear, it is not readable. So what we can do is just reload it, and it will give you some random color again, right? Let's see. Yeah, so you can see now we are clearly see it's a dog, right? And why we are like getting every time a new color, I will just discuss it in a bit when we will see the code, right? For now, let's just see what we can give next. So here is the image of a road, of a Pakistani road, and let's submit this as an input to our algorithm, right? And let's see the image. So you can see it's a road, a Pakistani kind of road, and you can see we are getting some cars. You can see we are getting some cars. These are our cars, and the rickshaws are like labeled as truck, because definitely this algorithm wasn't trained on the Pakistani traffic, right? So it doesn't know about these rickshaws, right? And a motorcycle has also been recognized, and a person. And yes, you can always like train the YOLO algorithm on your custom data set, right? So if you have a data set and you want to like train it, the object detection algorithm on that, you can always contact me through this WhatsApp, or maybe mail me at this Gmail, and we can arrange a Zoom session for that, right? Okay, so okay, we are getting the results, but let's just for the sake of understanding, let's just download some random image of a restaurant or maybe some other image, right? But let's go for restaurant for now. And yeah, let's save this image, okay, as maybe INP, right, on our desktop, and let's give this image into the model. Yeah, okay, we got some labels and let's see what it is. So yeah, it is like saying it's a wine glasses. Then what it's saying is a potted plant. Yes, it's a plant in a pot, and a chair, two chairs, right, and things like that. A cup, which is looks like a glass, right? But yeah, you can see it's working, right? It's working. And let's just discuss some things about the code. Let me just kill the terminal. And yeah, so what we are doing is like importing NumPy, importing OpenCV, and from within CV we will use the YOLO algorithm, right? Because it's like convenient to do on the local server, right? And then you can see we have YOLO weights, which we have downloaded from this link, right? I will give this link in the description, or maybe you can mail me or contact me through the numbers given below in the description, and I will just share the full source code with you, right? Or maybe we can arrange a Zoom explainer session. Let's see what we have here. Yeah, so we have like configuration file for YOLO and the weights, because we are using pre-trained weights as a transfer learning technique, right? So we'll be importing these weights and configurations for YOLO algorithm, which was trained on Coco dataset, and we have like Coco.names, all the classes of Coco, which can be person, bicycle, motorcycle, and a car, and things like that, right? And then we are just rendering templates, and in the uploader we are just saving our image, whatever the user will give the image, and then we are just detecting its class, and then we are just creating some boxes, and for the random thing we just set to create a seed of numpy random, right? And this is like random number, and whatever, like when we reload our page, so a random coloring system will be like allotted to our boxes, right? So we have like colors is equal to np.random, right? And for each class color will be different. So for all the classes which is like car, so all the cars will be of one color box, and then motorcycle will be of another color box, right? And then we are saving this the image as JPG file, and then we are showing this on our template output image, right? So yeah, that's it for today, guys, and I hope you liked the video. I hope you like the concept, and you can always contact me for the source code on the WhatsApp, or maybe mail me at the Gmail, and I will respond to you as soon as possible. Hi guys, it's me UBprogrammer, and today I want to discuss about a machine learning project which is spam ham email classification, right? So let's run our Flask app and see what we have built in this project. Let's follow the link for our server and you can see the interface. So as the project description says, enter the text of the email you are getting, and this intelligent web application will try to predict the email is spam or not, right? Let's just test it, the application, and okay, you can see okay, so this can be congrats, you have won a lottery ticket for free, something like that. This can be obviously a spam, right? Let's just submit it and you can see the entered email is spam, right? And let's just write a normal message. So hi, how are you, I will pick you up soon, right? This is the normal message which is not spam. Obviously we can sense that, but see, let's check our machine learning algorithm can sense that or not. Okay, this is ham, and ham is just a word that is like a negation for spam, which is not spam. We can obviously use not spam. Let me just do that quickly with our templates, and or maybe with our app, right? Okay, result will be not spam. Let me just save is at not spam string, and the server is restarting. Let's just reload it and you can see we are getting no spam. So the ham is just a negation of spam, right? Now let's just see a thing or two about our code. Let's just run our notebook, importing libraries and the uh, data set, and you can see the data set has some unnamed columns which has to be removed and dropped, right? Which is exactly being done here. Then we are just renaming columns, and then you are getting the clean data set, right? Ready to do like ready to be fed into algorithm by doing some obviously pre-processing. And then we are just saying in the category column spam will be 0 and ham is equal to 1. So in this category it will do that, right? And then we are just creating our input and output variable, and yeah, so this is train test split. And then the feature extraction is just converting a string which is your text of email into some features which can be detected or analyzed by your model, because your model, machine learning model, can't understand word it is, right? It has to be numerical values, right? So that's exactly what we are doing here. And then we are just implementing our model as logistic regression, and we are getting the accuracy of 96.6%, which is quite good, not bad, right? And you can use other model as well, and it is giving accuracy on training and testing data as 96%. Then we are just making a predictive system. And guys, this data set link will be provided in the description, or just text me if I forget about that, right? And this is the deployment part. So we have just, if we can show you in our notebook, we have just make a pickle of our model and feature extractor, which can be like seen here, right? And we are just loading both of them, and then we are saying if you are getting a post request, just save the text whatever the user will enter into a variable, then give that text into our model, and before that do the feature extraction obviously, right? And if the model says it's the give you return value of 1, then result will contain not spam, otherwise it will contain spam, right? Then we are just passing this variable into our display.html template. Let me just show you. Yeah, so and we are just getting text of email also, this text of email which was entered by the user, right? And then we are, if I can show you word wrap result as a variable, right, which will be obviously detected as not spam or spam, right? Let me just, yeah, okay. That was it guys for today, and this was just the pipeline, same pipeline which we have extracted from our notebook, right? So that was it for today, and this user interface can obviously be enhanced. I have just used simple bootstrap, so that's like I am not wasting any time for this part because I am busy in doing machine learning, deep learning projects, right? And you can contact me through this WhatsApp, or maybe mail me at this Gmail, or just check out the description for Insta and LinkedIn, and to get the source code, or maybe discuss about a machine learning or deep learning project, or a Zoom explainer session for any of the projects, right? Thank you.
Hi guys, it's me UBprogrammer, and I am back with another project which is calories burnt prediction. Let's just see the Flask app of our project. So this is the app, and with the heading calories burnt prediction app. So the idea is really simple. You do exercise, you burn some calories, right? So based on your duration of the exercise and some other parameters, we will apply machine learning algorithm to predict the calories or the amount of calories you have burnt, right, after the exercise. So we have this little project description, and which is obviously saying please enter the required information, and this intelligent website will tell you how much calories you have burnt, right? So let's just see a demo how this works. So my gender is male, age is let's say 51 years old, height is 190 centimeters, weight let's say 94, that's a lot of weight, right? Duration is let's say I have worked out for 29 minutes or 30 minutes, right? The heart rate is 105 beats per minute, and then you got the body temperature, let's say 40 degrees Celsius. So you have entered all of these parameters, and let's hit the submit button. So you got output as 207.36 amount of calories you have burnt, right, during that exercise or after that exercise. So that's the project, and if you just see this submit button, so when I hit that, it kind of switch between two text. One is please wait, we are predicting, and the other is the your actual output. Let's see how it's being the whole scenario done, right? Let's see the code of it. So when you get the source code of it, you can get it from the link in the description. So you will get all these files. In this you have this instructions to run the project. You can just follow out any of three methods I have described in it, and you will just know how to run this on your local machine. Or you can just text me out on this WhatsApp or mail so that I can help you out with the execution of the project, right? Okay, and let's just see the code of this project. So let's start from the app, because that's the main part. And if I just remove that, yeah. Okay, so you can see we have built this project on the Flask, or you can say deploy it on the Flask, and we are initiating our predictor. From where we are getting this predictor, it is in this file predictor.pkl, which is a pickle file. And how you can create this file is you have to do the data analysis on the dataset first, then you apply some algorithm like here. So this is the data visualization or exploratory data analysis part, EDA part. You got some heat maps, then you train the so in this project I have used the XGBoost regressor for doing the predictions, and I have trained this model on the dataset I have, right? And the dataset link is also included in the source code, so you can always visit that, right? And then we are predicting this, and this prediction is being what you can say displayed on the web page, right? And so the thing I wanted to show is you dump this model or your regressor into a predictor.pkl. so here we are getting this file. So we will create our model like that, and after that we have the predict function, which will predict the calories burnt based on all these parameters. And from where I am getting all these parameters, it's obviously from the app, right? And in the template I have index.html. so in here I am getting this gender, age, height, and all the parameters. And then with the help of some JavaScript, if you can see with the query selector and obviously get element by ID, I am changing this result ID with this inner HTML. First I am changing it to please wait. I'm doing prediction, so if anything goes wrong or it's taking so long to predict, it will show this message to you to the user, but it's really fast because it's a small application, right? So we actually see the result in a blink of second, right? So this result, and what is this result is, let me show you. This is the an ID associated to a h2 element or the heading element, and this h2 is basically our this output, right? So that was the whole project, and to get the source code you can visit the description. There will be a link about it, or you can just text me on this WhatsApp to discuss about your coursework or project if you are enrolled in any master or bachelor program, right? Okay, so I hope you like the video, and I will meet you in another project. Thanks for watching. Hi guys, it's me UBprogrammer, and I am back with another project, which is car price prediction, and this is an end-to-end project. That means we have built the whole Flask application where you can enter the parameters and you can see the result right now, right? And let's see what the project description is. Enter the required information and this intelligent web application will try to predict the price of car you want to sell. So you have a car you want to sell and just enter the parameters and you will know how much you should get after selling the car, right? Okay, let's fill out some values here. And so let's say the model of the car in which it was built is 2014. The present price in the showroom is, let's say, around 5.5 lakhs. Obviously the data is not really up to date because no one buys a car for 5 lakhs now, but that's what our data says. And kilometer driven is let's say 40, or let me just 20, yeah, 7,000. So I am getting this data to show you the accuracy of it, right? The fuel type is petrol because obviously you can't get diesel for 5 lakh. The seller type is dealer. The transmission is manual, and the owner, or this is the parameter which tells you how many owner this car have before you, right? So there was none, only me, and you can get the selling price should be 3.83 lakhs. So that is our prediction, and let's see the actual value, which is 3.35. so you can see the accuracy of our model is really great, right? 3.83 and 3.35 is not really far away, so we can rely on this model, right? So that was the first row of our data set, and yes, it is giving the accuracy on the test set also. So yeah, that is the data, car data.csv. The link of this data set is provided in the whole source code, and you can get the source code by visiting the description link, right? And let's see the code part of it now, how we have created this project. Let me just display this for a second. So let's see the app first, because that's the main thing. And as you know, we have deployed this with the help of Flask, and the model we have created is the predictor.pkl, which is a regression model, of course, because it is a regression problem, right? And how we have created this model is, let me just open the notebook and I will show you. So we have done some analysis on our data, then deal with the categorical variables, then training and testing part, obviously. Then we have linear regression model, but it was giving the accuracy, you can say R squared score is 87, right? And on the test set it is 83, so that's kind of good. But we have applied the lasso regression also, and lasso is also giving the 84% and then 87, so it is better than the linear regression. And we have plot some graphs on that also. Then we make a pickle of our regressor, which is of lasso regression, into a predictor.pkl file. So that's the file we are opening here or loading here, right? Because that is the model, right? Then we have the predict root, which is predict function, which is getting all these parameters from obviously the from here, right? And this is basically the index.html. So let me just go to the index.html, and in the index you got this all the parameters: year, present price, kilometer driven, and all that. And with the help of some JavaScript, we are showing the actual output, which is the output is this response text, and this is we are getting from this prediction, which is returning to the predict. So that's the kind of whole scenario of it, and that's what is being shown here, right? And that was the project. I hope you like this, and to get the source code you can always contact me on this WhatsApp or mail, whatever you are feeling comfortable, and or you can just visit the link in the description to get the source code directly. And if anything goes wrong with the execution of the project, just refer to this instruction to run project file. It will be in the zip file which you can download, right? And this is the method 1, 2, 3. So try to follow whatever you are feeling comfortable, or if anything goes wrong, you can contact me on this to get help in the execution of the project, right? So that was it for the video. I hope you like it, and I will meet you in another project. Thanks for watching. Hi guys, it's me UBprogrammer, and I am back with another project, which is medical insurance cost prediction. So you buy some insurance from the medical, and then it's kind of their analysis, the company's analysis on how much you can how much can be spent on you as their customer, right? So you enter your age, gender, and some health parameter, which is BMI, then children, and the region, and the your smoke condition, do you smoke or not, and then it will try to predict this much amount can be spent on you, right, if you are their customer. Okay, so that's exactly the project description is saying. Please enter the required information, and this will tell you how much money will be spent with the help of obviously machine learning algorithms. So let's just see the demo. This is the simple UI of our application, and let's just see the demo. So we have age, let's say 19, the gender is female, and I'm getting this value from somewhere. I will show you in a bit. And BMI is, let's say, 27.9. Then we have children, obviously not, because they're 19 years old, right? Are you a smoker? Yes, I smoke. And then select your region, southwest, right? Okay, and let's submit it, and when you submit it, you get output as $16971, right? This much amount can be spent on you, right? And let's see these values. So these was the values I was entering in our website, and you can see the charges. The actual charges was 16884, and what we have predicted is 16971 notes. So it's really awesome, right? They are not really far away, and that was the main motive. Okay, and let's see the code part of it now. And you can get this source code by seeing the description. There will be a link about it, right? So importing some libraries which will be useful in our analysis and model making. Then let me just show you the app first, and then I will explain a bit, right? So this is the app. and as you can see we are deploying it on the Flask. So we have imported this, and then this is the model, and from where we are getting this model is from this notebook. We are analyzing our data. This is the data, right? Then we are doing some visualizations on the data, and then after doing some EDA, I'm dealing with the categorical variables. Then we have imported the linear regression and we are applying it, and the linear regression is giving me the accuracy or R squared as 75%, which is kind of low, right? So what I have done is implemented the random forest regressor, and this is giving me the accuracy of 97%. So that's really cool, right? And that's why we are getting our prediction really close to our model or our actual values, right? Then we have made a pickle of our predictor as or regressor as predictor.pkl, and this file is being saved here, right? predictor.pkl. Then this file is being loaded into our model variable. Then we have the predict function, which is getting these parameters, and from where it is getting these parameters, let's talk about that now. Obviously from this web page, right? And this web page is basically the index.html of our Flask app, and here we have these parameters: age, gender, and from the input field we are getting the values. So if male has been selected, the value will be 0, female is 1, and from where this is coming from the categorical variables. I hope you remember it. Yeah, so male we have set it to become the 0 and female become it to 1, right? So that was the code part of it, and you can get the source code from the description, and you will get this as a full zip file, right? So you can extract all these files from there, and in this you can get the dataset link also. You can always visit that, and in that you will get the instructions to run your project. So there will be 3 methods. Choose whatever you feel comfortable, or by any chance you can't execute it on your machine, just let me know so I can help you out, right? So that was it for this video, and I will meet you in another video with another project, right? Okay, thanks for watching. Hi guys, it's me UBprogrammer, and I am back with another project, which is Titanic survival prediction. This will be an end-to-end project, so that means we have our Flask application ready, and it is asking for some parameters, and then it will tell you, as the project description says, whether you will survive or not on Titanic. So basically we have trained our model on the Titanic data, and then we will predict based on some values and see if our predicted values matches to the actual values, right? So that we can be sure about that our model can learn from the data, right? And let's see a demo. And sorry about this car price prediction app, because I haven't changed in the index. So let me just quickly do that so that no confusion occurs, right? So Titanic survival prediction app, right? This is the our app, and you can just tweak that in your source code, right? Let's just see some outputs. So let's say, and these Values, I really don't have much idea about it, but you can just go to the dataset actual link, which is on the Kaggle obviously, and you can learn it about there. Let me just show you. So this is the dictionary or the metadata about the data. So this P class is ticket class and things like that, right? Parch is children about the Titanic, and these are like all the parameters, right? Let's just quickly input some values. Let's say it's 22, and I am getting these values from our data, right? So that we can see if our model predict it right or wrong, right? So Wash is none because he is obviously 22 years old, and fair is, let's say, 7.25, and embarked is S. And what is this embarked? This is port of embarkation. So these are 3 locations, and we have selected S. And let's see, output not survived. So this passenger was dead, unfortunately, right? And let's see now from where we are getting this data. So this was the first row of our data. So P class 3, sex male, embarked S, and fair 7.25, and he actually didn't survive. So in the survived we have 0, that means not survived, and what we have predicted is also not survived, right? So this is the project, and let's see the code part of it now. And let me just show you the app first. So this is the app, and in the app you have obviously Flask, because we have deployed it on the Flask, and the model we are getting is the predictor.pkl, which is this file, and from where we are getting is obviously from this notebook. We are, let me just minimize it. Yeah, we are importing libraries, doing some analysis on the data, and then applying a machine learning algorithm which is acting as a classifier on that data, right? So here dealing with the categorical variables. This is for the embarked, this is for the gender, right? Then we are applying the regression a classifier. Logistic regression is a classifier, right? Classification algorithm on the data, and we are getting the accuracy as 80. We can obviously increase it by using some other classifiers such as random forest, or there are so many techniques to increase the accuracy, right? We can obviously do that. And this is the prediction pipeline, and then we are making a pickle of this classifier as a predictor.pkl. So that is basically this file here, which is being loaded into our model variable. Then we are getting all of these features or parameters from obviously this website from the user, and this web page is basically the index.html. So in the index we have this P class gender, and in the gender we have 2 options: male, which is value as 0, why 0, because if we see how we dealt with the categorical variable, it was 0 for male, right? So that's why it is 0, and female is 1 because female was when actually, as we are training the data. So in the testing we have to do the same, right? So that was the way to get the input from the user from this input field and from the selection field, right? Then with the help of this little JavaScript here with the query selector and event listener, we are showing this output, which is being predicted by our predict function here. So this is returning the prediction as survived or not survived based on this prediction. As if it's 0 then not survived, if it's 1 then survived, right? So this string variable will be passed into the passed as a return value for this predict function, and it will be passed eventually then to this response text, right, in the index.html, which is actually being shown here, right? So that was the whole scenario of the project. I hope you liked it, and if you want to get this source code, you can see the description link. There will be a link about it. You can easily get the zip file from here, downloadable zip file, and then you can extract it. And if you are having any difficulty in uh, execution of the project, just refer to this file, instruction to run project, and here I have written 3 methods. You can follow either of them, and if any by any chance you are not able to run the project, you can just text me, right? I will help you with the execution in your local machine. Okay, that's it for this video, and I will meet you in the next project or in the next video, right? Thanks for watching.
Hi guys, it's me UBprogrammer, and today I want to discuss about a machine learning project which is gold price prediction. So let's just run our app which is made by Flask and see what we are getting. Let's follow the link of our server, and here it is. So as the project description says, you have to put the required information, and this intelligent website will try to predict price of gold for you, like with the help of obviously machine learning algorithms, right? And what are these values? You can always Google them about it, and you can always check through this link which is of dataset provided in the description, or maybe just text me at the WhatsApp or Gmail for the source code, right? And let's just fill out these values. Just to give you an idea, these are values for some stocks and their indexes. This is for, I think, silver. I just googled them about a bit, and it's better to know your domain if you are working on a data science project, right? And let's just hit this submit button, and you can see the according to given parameters, the price of gold per penny weight will be these dollars, right? And this penny weight is a scale for those who don't know. Yeah, so you can see what is penny weight, right? Okay, so let's just see a bit about our code, how we have built this app, right? Let me just open my notebook and importing libraries, and the model we will be using is random forest regressor for the prediction part, right? This was the dataset. We have removed it because it's not like much effective on the price, right? And this was the target variable gold as GLD, and here we have just doing some analysis on the data, and you can see the target variable is gold, and the other variables other than date and GLD are the input features, right? Okay, so here we have just splitted our dataset into train test split with the 20% in the test data, right? And then used a random forest regressor with the n estimators or number of trees, decision trees, you can say A is 100. So the random forest algorithm is basically based on decision tree, just to let you know, and then doing some predictions, and you can see we are getting accuracy as 98.9%, which is quite good. And then we are just uh, making a predictive system, right? Then we are making a pickle of our regressor as gold price predictor.pkl, which is here, right? And let's see the deployment part. As always, importing the important modules to run our Flask app. Then we are just loading our regressor, and we are saying if you are getting a post request, then save those values in these variables and then give these variables into our model by converting into numpy array, right? And then we are just uh, getting the prediction as a float, and we are just limiting its decimal values up to 2 decimal place by this line of code, right? Then we are just passing this value as a result, and then we are showing this into our, okay, let me just into our variable in the display.html format or template, right? So that was it, guys, for today, and you can always contact me for the source code or maybe Zoom explainer session through this WhatsApp, or just check out the description, right? Hi guys, it's me UBprogrammer, and today I'll be discussing about a machine learning project which can detect or predict whether you have diabetes or not. So diabetes prediction system, right? Let's just execute our app and see what we are getting in this project. Okay, we got our Flask server. Let's follow the link, and here is the UI for your app. So asking for some parameters, medical parameters, and the first parameter is number of pregnancies, and you are wondering why, if you are a man, and why it's asking me for that, because the data set I got was only for the woman, so I just built the app on that, so it can be only used for women, right? And let me just quickly what the project description says is required information you have to fill out, and it will tell you whether you are a diabetic patient or not with the help of obviously machine learning algorithms. Let me just fill out some values, and you can like always Google them about a bit, which is better for your domain knowledge in the data science project, right? And you are getting you are a diabetic. It is like replicated, but you can remove that any part, right? You are a diabetic patient, right? And let me just see how we can check that. Yeah, so let's just remove that and add patient here. Okay, let's see if we are getting our syntax better or not. Okay, yeah, great. You are a diabetic patient, right? So let's just talk about our code a bit. Let me just open the notebook from where we have built our model and store it or save it, right? So importing libraries, importing the dataset, and dataset link is here, which will like provided you in the description. And then some analysis on the data set, and then we are just uh, standardizing our values a bit, because uh, if you see the data set, like this number and this number, they are like not in the same scale, so it's better to feed values within the same scale uh, to increase the accuracy of your predictions, right? So we have just used that, and then train test split, and we have used sport vector classifier with the kernel linear, and we have got the accuracy 78.6%. It can definitely increased by doing hyperparameter tuning, but for the sake of just doing the project and deploy it on the Flask, I have just uh, I'm just happy with that, right? So we have just predicting some new values, and then we have just make a pickle of our model and the scaler, because we will be scale the new values and then give it to our model. So let's see the deployment part. We are just importing pickle, and then loading our model and scaler, and then we are saying if you have like got the post request, save those values in these variables, and then give them into the model as a numpy array, right? And if the model say value of zeros as a prediction, then you will be saying you are not diptych, and if it's say give you the prediction as 1, then you will say you are diptych, right? And then we are just passing the result into our display.html template and showing it here, right? So that was it guys for this project. I hope you like the project, and you can always contact me through this WhatsApp and this Gmail to get the source code and maybe a Zoom explainer session if you want me to do that, right? Thank you. Hi guys, it's me UBprogrammer, and today I'll be discussing about a deep learning project which is breast cancer classification. So let's just run our app and see what we are getting as user interface. Okay, let's just restart it. Yeah, here you can see we have used TensorFlow Keras for doing the classification, and we are getting all these warnings just because I don't have GPU setup currently on my machine, right? So this is like the interface for your Flask app, and it is asking about some parameters, right? Which is like your health, and this can be like obviously obtained from your medical reports. And then we just submit it, and it will classify according to these parameters, like if you have a cancer of which type, right? Benign cancer or malignant cancer. So as the project description says, like enter the required information, and this web application will try to predict whether you have a benign cancer or malignant cancer, right? With the help of deep learning algorithm ANN, which is artificial neural network. So let me do just one thing, like I will fill out these parameters. Let me open my notebook, and if I can show you the data set. Yeah, so this is the data set. So I will just copy paste a row from here and submit these values into my Flask app, right? So let me do that. So I have uh, input some parameters, according to my data set, and let me just hit this submit button and see what we get. So it is saying you have benign cancer, which is obviously predicted according to those parameters which has been entered here, right? So let's just see the code where we are getting this model and analyzing our data set. So this was the data set, and I will be like giving this dataset link in the description, or you can just contact me for the whole source code of this project through this WhatsApp, or maybe mail me at this Gmail. Let's just see a bit about code. So this was the dataset, some parameters, which is obviously you have to like get some idea of this domain. I have just googled it a bit, and then we are just analyzing our data set and then train test applet, and we have just applied a and n, and for a and n it is like must step to use the standard scaler. It will always like increase the accuracy for you. So we have done that, and the accuracy we are getting is 94.7%, right? Which is quite good. It can be increased obviously by doing some hyperparameter tuning or grid search CV to find the optimum parameters, and then we are just building a predictive system. So let's see how we have deployed it into our class cap. So we are just saying if you are getting a post request, just collect these variables, right? All of them are variables, and store their values into their respective names, and then we are just giving the input data as a numpy array to our model, and if model says like it's 0, then result will be malignant, and otherwise it will be benign, which is if model says it is 1, right? And then we have just get our result and displayed it into our display.html template, which is here, right? So that was it, guys, for today. I hope you like the video and the project, and you can contact me for these projects through this WhatsApp, or maybe mail me at this Gmail, and just check out the description for more details, right?
Hi guys, it's me UBprogrammer, and welcome to this amazing video in which I will be explaining the source code and give you a working demo for 10 machine learning and deep learning amazing projects. Some are from machine learning, some projects are from deep learning concepts, and you can just check it out in the further video. And I want you to know, if you are enrolled in any bachelor or master program, you can contact me on this WhatsApp or email to discuss about your coursework or projects you are working on. Okay, so let's get started with our video. Thanks.
Hey guys, it's me UBprogrammer, and I am back with another project, which is handwritten digit recognition, right? So we will be doing this project with the ANN, the deep learning model, artificial neural network, and let's just see how our app looks like, right? So let me just create a new terminal and execute our app, right? Okay, you can see I'm getting the warnings of GPU setup. We can totally ignore that if we don't have GPU, and this server has been created for us, right? And let's see. So this is the simplest like UI you can get, and the title says handwritten digit recognition using ANN. So the project descriptions says that please upload an image of handwritten digit, and this intelligence will vary to predict what has been written on that image, right? So let's just choose a file or a image, right? Let me choose this one as an example, and let's just feed it to our model, and you can see our model has guessed it correctly. This image contains the digit 3, right? So whatever the digit it will be recognized, it will show us there, right? And let's just do one thing. I'll just open my paint, and I'll just write something there, right? Let's just write 5. Okay, and let's see if we feed it to our model and it will give us correct result or not, right? So if we save as a image as I don't know, input to our model, right, on the desktop, and I just close it and give that digit to our model, right? And let's see if it's working or not. So you can see it has guessed it correctly or predicted correctly, right? So the model is working, and let's just see the code a bit. And if you want to discuss more about this source code, or maybe wanna get it as a downloadable file, so you can always contact me through the WhatsApp number or the Gmail, right? And these are given in the descriptions also, so you can check it out. Okay, let's discuss a little bit about our code. And you can see I have created obviously a Python notebook where I trained this model and like save it as my model for future prediction. So I just use the dataset which is already present in the Keras, right? Keras is the library for deep learning. I'm sure you have an idea about it, and I'm just this dataset already is separated into the X train, Y train, and X test, Y test, right? So we just have to create the variables for us, and this is the format. Like you can't do anything wrong about it, right? The syntax has to be followed. And then we can just show a sample from our training set, which is like this 4, and then we are just creating our model because it's a multi-class classification problem, so we have to use the softmax layer as the activation layer in the last layer of our model, right? And then we are just compiling it and fitting it, right? So you can do all this on your machine and collab also. So this is not any heavy data set which will consume a GPU or something like that, so you can easily run it on your machine. And if you have any problems, you can always contact me on the WhatsApp so that I can solve it for you. And then we are just making predictions, and the accuracy you can see I'm getting is 97.8%, and it can be obviously increased by using grid search CV or hyperparameter tuning and things like that, but I am happy with that because I just want to deploy it on the Flask and create a project about it, right, where I can use any image, right? Okay, and then I just saved it my model as digit recognizer.h5 file, and you can see it is showing here. And then I just created a pipeline, a custom pipeline for any new image, if I save image as the from the snippet tool, or maybe download it from somewhere, so I can pass it to this pipeline, and it will convert it into NumPy array for feeding it to model, right? And then I am just here testing my pipeline so that it can like predict when it will be dealing with our flask app. And then this is the code for our flask app, and you can see we have like load the model from this keras dot load model function or method, and then we just if we are getting a file from our uploader, which is in the uploader template. If we are getting file from this, right, uh, then we are just parsing it here and giving it to our pipeline. This is the same pipeline which I have showed you in this testing pipeline notebook, right? So this pipeline and this pipeline is the same, right? And we are just saving our result, which will be like the value of the digit predicted by our model, and this commented is also the same pipeline. So let's just get rid of it, and yeah, we are just executing it by app.run, right? And then we are just passing our result, which is predicted digit, and the input image whatever user has input. And in the uploaded.html template, we are just showing our input image and the result, which is predicted digit. And these like brackets shows that it will be a variable, right? And this value can be changed. And index image, what it contains is like it is containing a form through which we can upload image, right? And it will be passed and then to our pipeline, then to our uploaded.html. So that was it, guys. I hope you like it, and if you want to talk more about this project, or maybe you want the source code, you can always contact me on the WhatsApp, and I will just arrange a Zoom explainer session, or maybe arrange some explainer sessions about other projects which you can recommend to me, and we will see you there. Hey guys, it's me UBprogrammer here, and today I'll be discussing about a project in which we can detect age and gender of the subject, right? So let's just run our app and see what we will be building in this tutorial. And if I just run straight the app, and this is a Flask app, right? So you got a title here, age and gender detection, and it's asking you to upload a file, and obviously you will be uploading a file which has a face, and the project descriptions actually says that please upload an image with a face, and this intelligent website will try to predict age and gender, right? And with the help of deep learning, right? So the model behind the actual scene is deep learning, and we have used the pre-trained model. So let's just give you a demo, and here you can see I have a picture of Mr. Modi, the Prime Minister of India, and if I just upload this image and submit it, so you can see I got the results, and it's zoom in a bit. Yeah, that's the actual size. So you got the original image shown by our Flask cat, and then it just processed the original image and detect the face, and gave a bounding box around that, and detect the gender and age, and you got the label as output image. So let's just zoom in a bit to see our prediction clear. So you can see our model has predicted this subject as male, and the age of the subject is 38 to 43, right? So let's just give one more, and if we just reload it, you can see the cache has cleared. So if I just go down to my folder, I have a picture of Mr. Imran Khan, the ex-Prime Minister of Pakistan, and just submit it, and you can see the original image and the output image. And if we zoom in a bit, this image, you can see model has successfully predicted that this man is a male, and subject is a male, and the age is 25 to 32, which is like quite less than his actual age. But yeah, the lightning and the other parameters of the image can definitely affect the behavior of the model, right? So you can see the maybe the image has just recognized the white hairs on the face, and that's why it's predicting 38 to 43. I don't know the actual age, but yeah, we are getting results, right? So it's mainly about the deployment. So whenever you are trying for a position in data science or machine learning, so the actual practical aspect of that job will mostly be the deployment, and right. So the image building, let's just discuss about it. This was the flask app. Let's just control C to quit. And yeah, so we have just used our models, which are like giving us the pre-trained weights. uh, the model is called the cafe model, and yeah, we just use pre-trained weights of these models. If I can show you like this, so these are 6 models, and we just imported and use their weights to like detect, and then we just build a flask app to grab the image, make a uploader, and then processes with this deep learning model, and then our app will be like showing us the results, right? And this model is pre-trained, and this technique is called transfer learning, right? So, and the static directory in which the uploaded image and the output image will be saved. So you can see the image is this and output is this, right? And this exactly was being shown us to in this format, which I have just built by using the HTML and CSS, right? So this was the small project. You can show this into your maybe school or whatever, wherever you want it. And to discuss more about this source code uh, about this project, you can always contact me on WhatsApp, and I have given it in my website and description as well, so you can mail me, and the email is also provided, and you can text me on WhatsApp. So maybe we can arrange a Zoom explainer session to just give you a demo about the project and discuss more about source code, right? So this was it in this video. I hope you like the project, and uh, I will try to make some more projects and explainer videos in the future. So do subscribe the channel, UBprogrammer, and I will meet you in the next video. Thanks. Hey guys, it's me UBprogrammer here, and today I am back with another project, which is traffic sign classification system, or you can say traffic sign detection system, right? So let's just run our Flask app and see what we have built, right? And if I run my app.py, I am getting warnings because I don't have GPU set up on my machine, and so let's just ignore that because we have already trained our model on Colab, right? And you can see our user interface of the model, which is quite simple because we just wanna deploy it on Flask somehow, right? And what the project description says, like upload the image of a traffic symbol and we will predict what it means, right? Our machine learning model predict what it means, right? We obviously know that. And if we choose image of this symbol, which is turned right? We obviously know that, but let's see if our machine knows that, if our machine learning model predicts it's right or not, right? So you can see the traffic sign means turn right ahead, right? And I have used like Bootstrap mainly for the CSS part, so because I just wanna focus on the deep learning part, right? Coding. And if I just do prediction on another image, it's turn left ahead obviously, and it is given turn left, and then I just done one more, and you can see it is a blurry image, but our machine learning model can predict it, right? The speed limit 50 km per hour, and see it, right? So let's just see our code, and first of all fill our terminal, and here notebook, right? Okay, so here I just ported the libraries which I will be using in the project ahead, and then I am loading my dataset. And this part, the training part, I have done on the Colab, right? Because obviously it is CNN, a heavy model, and the dataset was also huge, and I can't like execute on my own machine because of like I don't have GPU and hardware. So you can see the classes in our dataset. So let's just uh, show you this. Yeah. So we have like classes, and I have put it in a dictionary. 43 classes we have in our project, and you can see each class contain different set of images within it, right? So you can see 20 kilometer per head speed limit is one class which contains the images of that particular class, right? And just like that, we have 43 images, 43 classes which have different set of images for themselves, right? And then we just printed the distribution, or plotted the distribution to see if our data set is how much balanced and not. So we are getting the idea it is balanced, and we will keep like care of that, take care of that. And here just I'm just like making a pipeline for uh, feeding the images to our model, right? And then uh, I here. So I have like printed the model load summary, and you can see the layers and uh, other parameters of CNN which I have used, and then I have just fit this model on our data set, and I have entered accuracy somewhere. Yeah, so 97% was the accuracy score which I got, and this can be like obviously improved by using other techniques, hyperparameter tuning and things like that. And grid search CV can also be helpful in this case, but I was happy with the 97%, and we can just deploy it on Flask, right? So to save our model, I use like a model.save, and then just save my model as my model.h5 file, right?
and from this model I can just load it anywhere and make some predictions on new images, right? So here I am like uh, making predictions. So I just load my model here and then make a prediction on that image, and you can see I am getting this predicted sign belong to 34 class. So if I just check 34 class, it is turned left ahead, and this was the image was also the turn left ahead. So and that's how we are like getting predictions, and then I just deployed it on a class app, and you can see here I am just getting the result as the integer, which is like classes is the dictionary here, and I am like getting this number from my model, right? Model prediction. So I'm just passing this number into the classes to get the string, right? I hope you like know that. And if you like wanna discuss about this source code and other things about this project or any other project like that, you can always contact me from the numbers, WhatsApp number and email in the description below, and we can just arrange a particular Zoom explainer session. And then what we have, yeah, let me show you the templates. So this is our bootstrap, and you can see we are like getting the input as a file and then saving it in our static directory, right? As we have configured it here, right? The upload folder is static, and then we are showing this as a sign name, which is passed as result, right? So the result is the string, and we are passing it as the sign name in our uploader uh, template, right? So, and this is the input image. We have also like passing it from here, right? And this image will be like obviously inserted or uploaded by the user, right? So, and this was the user interface. So this was it, guys, and let me know if you wanna know more about this project or any other project like that, or maybe wanna get the source code to somewhere. And you can like always contact me on this WhatsApp number, or maybe mail me at this number with my website, and I will reply you as soon as possible. Thanks. Hi guys, it's me UBprogrammer, and today I want to discuss about a deep learning project which is dog cat classifier. Right, so let's just run our app and see how it looks like. I've deployed it on Flask, and you can see I'm getting warnings because I don't have currently GPU setup on my machine, and it has successfully created our server, right? So let's follow this URL, and this is our Flask app, right? So what you have to do is like give the input as an image of a dog or a cat, and this machine learning or deep learning algorithm will find out and predict it's a cat or dog, right? That's the like main motive of the project, and you can see as the project description also says it. So let's just do one thing and give it some input as this dog image. We know that it's a dog, but let's see, our machine learning program has also says this image contains dog. So this value will be like changing as the image will change, right?
And let's see if we give an image of a cat and submit it, so you can see that this image contains a cat. So this is the projects. Let's do one thing, that let's just search dog and try some random image from the internet, right? Which dog, let's see how this one goes. Let me save this one on my desktop as, I don't know, INP. And okay, and let's just give this image as an input and see how our algorithm works on that, right? And if we submit it, this image contain dog. So because the accuracy which we got was around 98%, so this will work properly, right? And let's see our code. And for this source code as a downloadable file, or maybe you want to get a Zoom explainer session, you can always contact me on this WhatsApp, or maybe mail me at this Gmail, and I will try to arrange a Zoom explainer session for that, right? Or maybe you want to just get the source code of this, right? You can check out the description. So let's just discuss about source code a bit. This was the my notebook on which I trained and export the model as dog cat classifier.h5 file, right? It is opening up, and is taking a time. Let's discuss about this one first. So I just created a model on my inputs as training data. Let me just show you where we have training data and where it was. Yeah, so this was the training data. I downloaded it from Kaggle. I will give the description in the I will give the link in the description below, right? You can also download it from there, and you can see we have 25,000 images in total, and exactly 12,500 for cats and 12,500 for dogs, right? So this was our data set, and we trained a model, or you can say we just tuned the model, tuned the weights of pre-trained model uh, on this data set, because we have used transfer learning for our project, right? And this file is also open. You can say I have printed the number of uh, images in my dataset with the help of Python OS library. And then let me see if I can run this. Yeah, and then if I just show you, these are the file name, image names, right? And let's just clear this output, and you can see I have shown some images, and you can see 12,500 was dog and 12,500 was for cat, right? Then we have to obviously resized all the image for giving it as an input to our model, because the model we have used accept a particular files particular size of the images as 224 by 224, right? So we have just resized it, and then we just label is that cat is equal to 0 and dog is equal to 1, just to give a numeric representation to our data set, right? And then we have just converted into numpy array, because we are obviously giving it to our model as an array, and then train test supplet, then scaling the dataset, and then we have used this mobile net model, which is like pre-trained CNN, and we have imported this model as, and we have just tuned the weights according to our dataset, right? And this approach will like always give you the better accuracy. And if I just show you, yeah, the test accuracy was 0.97.7%, right? So around 98% you are getting the accuracy, right? And then we have just check our model if it's doing the predictions. And then for the deployment, I just make a pipeline like to handle the new images which we will upload on our app, right? I just let me just show you where. So we just saved our model as model.save and doccat classifier.h5, and you can see the file here. Then we just loaded our model, and you can see we have this pipeline on which the new image will work, right? So if you just change the image file name here, the results will change accordingly, right, according to the predictions of our model. And then if I can show you in my app.py file, I have implemented this exact same pipeline which was there, right? But we are just storing the result in a result variable and then passing it in the render template to show it on the on our web app, right? And if I can just show you in my uploaded, where I am showing you the result, so you can say this result will change according to the predictions of our model, right? And first of all I will show the image and then the results. So that was it, guys. I hope you liked the video, and if you want to like discuss more about the source code or maybe want to download it, you can always contact me or text me at this WhatsApp or mail me. And for these other projects of machine learning, deep learning, artificial intelligence, I will be always available to help, right? Thank you for watching this video. Hi guys, it's me UBprogrammer, and today I'll be discussing about a project which can detect about the heart disease, right? So let's just run our app and see what we have built. So this is the Flask app, and we have started the server, and this is the like simple UI for the app, and it's asking about some parameters about your health, and then it will predict whether you are a heart patient or not, right, with the help of obviously machine learning algorithms. So let's just give some input, and for this project I want like you to know that domain knowledge plays an important role, right? You have to know like serum cholesterol and resting blood pressure or whatever the other parameters of health are, right? And you have to like have the information about them in order to like do feature engineering and other stuff. So I just googled them about them a bit and got a like mandatory knowledge, and let's just give some parameters like male and 0 resting blood pressure. Okay, so I really don't have like much idea about these values, but for the sake of our deployment of this machine learning project, I just like googled them about a bit, right? But you are, yeah, so you are not a heart patient, and if the values you adjust it according to heart patient or like abnormal values, so you will get like you are a heart patient, right? And let's just see the code and see. uh, Let me just open notebook from where I have exported a model, right, and do the training part. So importing libraries, and this is the data set hard.cv. I'll be giving a link in the description, or you can always contact me through WhatsApp, right, through WhatsApp, or mail me at this email, right? And this was the data set. So you got age, sex, and these other parameters like cholesterol and some other thalassemia situation and other stuff like that, right? And uh, so I just did some EDA on this, and then I just make my input and output variable by the indexing, and then the train test split, and when I applied the logistic regression, I got the accuracy about 85%, right? So this was like good enough for me for the deployment purpose and like as a practice project. So I just imported that model, and you can try other models as well, right, to improve the accuracy, or you can just ask me to do it, right, do it for you. And then we are just printing the result, right? And let's just see how we deployed it, right? So we are getting these values and storing the values in the variables from our website, right, from this part, right? So whatever the user will enter here will be stored in these variables, and then we are just giving this as the input data, and then the input data has to be converted into numpy array in order to be fed into the model, right, which we have imported here, pickle.load, right? And then we are just, if prediction is equal to 0, then obviously not a heart patient, because target variable 0 represent not a heart patient, and else result is equal to a heart patient. And then we are just concatenating the string with the template, where we are just showing this UR and then result, and result is what I have already shown you, that result is this string, right? So this was the project, and this was the the pipeline which I just made here while predicting system, right? And this was the project through which you can enter health parameters and check whether the person is a heart patient or not and predict it, right? So you can get this source code by contacting me, or maybe mail me at this email, or do the WhatsApp, and check out the description to get the source code, right? Thank you. Hey guys, it's me UBprogrammer here, and today I am gonna be discussing about a project which is student marks prediction. So let's just jump right into what we have and what we are gonna build. So if I run my Flask application, it will create a server for us, and we will visit this website, right? And this can be obviously hosted online. So this is like main interface of the project. I want to tell you guys, this is a very beginner friendly project. So if you are new into data science or machine learning, so you can contact me with the contact numbers below, and I will be discussing more about the source code and other things about this project, right? So this is the floss application, and you can see I got the navbar here, and the heading says student marks prediction. And I have added a little bit description about the project. So what you have to do in order to use this application is enter the study hours per day, right? So how much you are gonna spend in studying, right? How much time you're gonna spend in studying per day, and obviously the 1 to 12 hours is should be range, and we can't study more than 12, or maybe some other some people can, right? But this is like general. And this intelligent website application will try to predict your marks percentage for the exam with the help of machine learning algorithm, right? And let's just write a number. So let's say I will study 4 hours a day, right, for my exam. And our machine learning algorithm say you will get like 66.19% in your exam. Good luck, right? So how this like machine learning algorithm works, and why this is saying like I'm getting 66.19%, because we already gave our machine learning algorithm a data. Let's just do one more prediction and we'll talk about code. Then you can see if I just increase my number of hours, so this is obvious, like I'm getting more marks, right, in my exam. So let's just go to our main project, and as a data scientist you should know that, let me close it down, you should know that for making the project and do like data analysis, you should use Jupyter notebook, which is like IPYNB Python notebook. And so let's talk about code now, right? So I imported the libraries which will be like I'll be using further. So what was my data, right? So let me just show you my data. It contains the study hours and the student marks, right? So if a student is studying like 6.83 hours, or you can say 7 hours, he is getting 78.5. I just took it from Kaggle. I think you should know about it, right? You all have the idea about Kaggle. And I just loaded the dataset, and you can see our dataset contains two variables, or you can say one feature and one label, right? This is the label, student marks, and this is the feature. And you can see we have like 9 values, and these empty values should be taken care of. We will take care of further in the project. And this was the head, and this was the tail of our dataset, and shape and all that, and like info, basic info, the stats, basic stats about the project. And I have already made videos about these in my other channel, so you can just Google about it, or maybe call me with my number in the description below, right, if you have any doubts about the project. Okay, so we just plotted student study hours and student marks in our matplotlib library, and you can see a linear relation. So as the study hours increases, student marks are also increasing, right? And then you can see we have some null values. So I'm just replacing it with the mean, right? The average of the study hours. I will just replace these non values, and you can see fill NA, and I have filled it with the mean of the study hours, right? And then we just do the train test splitting, and then we train our model on that. I just applied the linear regression, and the accuracy was good enough for me. So I just wanted to deploy in on Flask and like get the idea of the variables which I'm using, right? Like how to send data from HTML to Flask and Flask to HTML and deal with with that data with the help of machine learning algorithm, right? This was the main motive of the project. And yeah, so we just fit our machine learning model on our training data, and then we do some predictions on the y predict, like our test variables, our test data set, you can say. And then we just concatenate these two variables, which was like original marks and the predicted marks. So you can see 82 was original percentage the student was getting, and our model predicted that the student will get 83.1, right? So there is very little like difference, right? And then I just find the accuracy of my project, which is 95%. Not bad, but this accuracy can definitely be increased by using other models for regression, so we can always do that, right? And you can see the like we are getting almost 10 to 12 decimal places, right? And this this percentage will be like we will tune it into up to 2 decimal place. So I will tell you how, right? And then we just for verification purpose, how our data is like our model is performing, we just plotted it, and you can see we are getting a linear relationship again, right? And then I just dump our model and make a pickle of our model with the help of joblib, and you can see I got this file, right? And okay, this file I'm getting, and then I can just use my model and make predictions, right? With the help of like this command. And now the main thing after you like make a model is deployment, right? Because nobody is going to see your notebook and like do stuff with your code in this command line, right? You have to give them a web application to which user can interact, right? So I just make a Flask app which is like rendering a template. Let me show you the template, and I use Bootstrap for the CSS part because I mostly focus on the machine learning algorithm and that part only. Okay, so there is a form which asks the for the study hours, and then the study hours will be passed into this variable, right? And then this study hours is a string. We have to convert it into an integer in order to feed it into our model, right? So then we are like this is the same command. If you just recall it, like this command, this 5 is you can say replaced by the whatever number of study hours the user will enter, right? And then with the help of this command, string formatting, we are just limiting the floating value up to 2 decimal place, right? And then we are rendering this template display HTML with the marks, right? We are like passing the marks into display.html, and in display.html you can see I have like written this you will get, and then this marks whatever our model will be like giving the result. With the help of this predict function we are displaying it there, right, in your exam. Good luck. So this was the project, and if you like want to talk about the source code, or maybe wanna get it, or do some other projects like that, and you want a mentorship program, do like the video and contact me from WhatsApp, right, or mail. Like you can go to my website and you can see my WhatsApp number or mail, and I have written that in my description also. So that's it, guys. For today, I will come back with the next project very soon. Hi guys, it's me UBprogrammer, and today we will be discussing about a machine learning project which is wine quality prediction system, right? So let's just run our Flask app and see what we have built, right? So I'm starting Flask app, go to the server, and this is the UI of our app. So it's a simple form which is asking for some parameter, obviously, which you can get some idea if I can show you the link of the dataset, right? Okay, so this was the dataset on which the whole app is built, and you can get some idea about all these columns from this link, right? I'll be sharing this with you in the description below, right? And let's just put some values. Let's do one thing, that if I can show you my notebook from where I did the EDA and all with the data, and yeah, so from here we can just copy paste some values, because I don't know about all the values of all this stuff, but yeah, you should do some research about the domain on which you are working with, right? So if you are working with the data about wine, so you should have some idea about all these parameters, right? But for the sake of this demo video, I will just try to copy paste these and see if the results we are getting is same according to our data, right? Okay, let me just copy paste it. Okay, last parameter, let's just put the value and hit this submit. So you can see we are getting, you have bad quality one, right? And this was obviously the result. You can see here also bad quality one. So it's clear, right, that our application is working well. Let's see how we have built this model, and if I can show you the data set, which was this, I loaded it into Jupyter notebook, then some EDA on it, and then applied random forest classifier model, right, which will always like give you better accuracy than other regression model. You can always like play around with it. Random forest classifier, and we got the accuracy about 93.1%, and then we have just deployed it into our Flask app. So these are all the features which we are getting from the user from our app in the index, right? So this was the form. We are getting these features, and storing these values in these variables and then giving it into our input to our model, right? And then whatever the result will be like stored in the result variable, and then we are passing this variable into our display template, right? So this result will be shown as you can see here. And you can always like if you want this source code, or maybe you want a Zoom explainer session for this project or any project like that, you can always contact me on this WhatsApp number or maybe mail me at this Gmail, and I will respond as soon as possible. And that's it for today, guys. Thank you. Hey guys, it's me UBprogrammer, and today I'll be discussing about a machine learning project which is Mart sales prediction, right? So let's just see how our app look like. Here I am starting my Flask app and it will give me a server. Here we have our server. Let's follow the link, and this is the simple UI of the app. And as the project description says, enter the required information obviously about a product, and this intelligent web application will try to predict sales of concerned item, right, of the product. So let's just put some values. I'm just entering some random values. Okay, and these are just features of my training data, right? So yeah, let's choose some values, and when we hit this submit button, this data was will be filled into our model and machine learning model, and our result will be generated, right? So this will be a variable which will be changing according to prediction of our model, right? Okay, so yeah, let's just see the code and try to understand how we can create this, right? And if you want to like get this all source code, you can always contact me through this WhatsApp number, or maybe mail me at this Gmail, and I will reply you as soon as possible, right? And okay, so let's see the notebook first. And yeah guys, we can actually arrange some Zoom explainer session for all the code and for any project you like, right? Okay, so importing libraries, loading the data set. You can see the data set, some first rows, and you can see the these are the same parameters which we are getting through user, right, from our app. And some info about data set, and you can see we got null values, missing values, so we have to handle that. We will just use the mean imputer for this missing values issue, right? And then we are just handling the missing values, and you can see we got no missing value this time, right? Then some EDA on our data set, which is like obvious if you wanna build a perfect model. And then you can see I am removing some columns because these columns will not be like helpful in our model building, right? These columns don't play any like significant role in the sales of the item, right? So we will just ignore or remove these columns, and this is the data set which we will be training our model on, right? And then I am just printing the unique values. I'll be telling you why I did that. And then with the categorical features, I just apply the label encoder, right, from the sklearn obviously, and then we got converted our categorical features into numerical form, right? Numerical form. Okay, so here I am like again displaying the unique values, and yeah, so then we are just making the input and output variable, and on the model training we just trained a separate, and then we applied XGBoost regressor model, and you can see the accuracy was 0.84, which is 4%, not bad, but we applied random forest regressor, and this gave us the accuracy about 93.6%, right? So we just make a pickle of that model random regressor as a sales predictor.pkl, which is this file you can see, right? So let's talk about deployment and why I am like displaying these unique values again and again, right? So you can see I am getting these features, these variables from the form which I have in my index in my home page, right? And these values like low fat has a value of 0. So let's understand this concept, right? So let's just check. So this is the fat content, right? And you can see this fat content has the value of low fat is equal to 0 and regular is equal to 1, right? So you can see if we count the values, it is giving a 5517 belongs to 0 and 3006 belongs to 1. And when we go before that label encoder, we can clearly see that 5517 was low fat and 3006 was regular, right? So I applied this concept into my deployment part, and item fat content in this variable, in this features, I got low fat is equal to 0 and regular is equal to 1. So whenever a user will select, let me just go to, okay, whenever user will select low fat, and I'm selecting low fat, what value will be like I'm giving to my model will be 0. And how I'm doing this, I'm just declaring it here, right? And then this value will be saved, 0 will be saved into this variable, right? And so on with all the other these three categorical features, right? And yeah, so this was the app, guys. I hope you like this project, and if you want me to arrange a Zoom explainer session for a private session, you can always contact me through these numbers and I'll be ready to help. Thanks. Hi guys, it's me UBprogrammer, and today I wanna discuss about a project which is Islamabad house price prediction. So let's just start our app and see what we have built and how it's look like, right? So you can see it is starting out and we got our server. So let's follow this link and you can see the interface of our app. So this is the simple app, and as the project description says, like you have to enter the required fields and it will predict the house price for you. Okay, so let's select some parameters for our model, and let's say I want a house in a sector F6. Okay, it's the location in the Islamabad, and I want area in Madla as, let's say, 5 Madla. So I want, and who don't know Madla, for those just you can get the idea in the square feet, right? So 5 Madla will equal to this much square foot. Okay, and number of bathrooms, let's say 3, number of bedrooms, let's say 3. Okay, so when I hit this submit button, all of these parameters will be fed to our model, right? And you can say you have to pay. So this price was like predicted by our model to buy a house of, and that was the information which we have put in the website, right? And good luck. Yeah, so let's just change a bit, and let's say if I just uh, increase some modulas, so as the area increase, price should increase. So let's see. Yeah, we have to pay a lot, right? So it's in lakhs, and you have to pay like 113 lakh in order to get. Okay, and let's just change area a bit. Let's say E11 and submit it. So you can see price is increased. One of the reason can be like E11 is the more posh area than the F6, right? So that can be a reason, and our model has recognized the pattern in that, right? So let's see how we have built our model and what was our data set. And let me just close this one. We will come to this one later, how the deployment part. Let's see the notebook on which we have performed the exploratory data analysis part, right? So I'm just importing the libraries, and this was my data set which I got from Kaggle. I will give the description link in the description so that you can do things on it, right? And that was the head of our data. So let me just close it, and you can see that it got price, it got location, it got city, and it was the dataset for whole Pakistan, right? So I am just interested in the Islamabad for this project, so I will just choose this rows with only city as Islamabad, right? And we will do it in a bit. Okay, so these was like the variables which I got from the data set, and it was collected by zameen.com, right? So we can say it's a variable source, right? Okay, and here you can see like I am only selecting rows which in which city is equal to Islamabad, right? So I can't like I am not interested in the prices of whole Pakistan, so I am just doing it for Islamabad, right? And then I am just property type is equal to house, right? So I don't want flat in our data set, or I don't want like plot which is like which will like create a big difference in prices, right? And then we have like purpose for rent or for sale. It will create a lot of impact if we just do it for both. So I am just interested in house price prediction, so I am just doing it for purpose for sale, right? And then house price, I am just dividing my house prices by a lakh, right? Because this was like a very bigger number. You can see, if we can see the price, yeah. So this is like 1 crore, right? And you can see like these zeros will confuse our model, right? So we have to like get it in scale. And then I just create a box plot to see the outliers in our price, and you can see after 4,000 it's quite like you can say these are the outliers, right? So I'm just removing those, and then just printing the shape, and then yeah, so this was the column, the first column, which is unnamed, and we obviously want to remove that. So here I am removing that column, and some of the other columns which will like don't impact the price of the house, like latitude, longitude, we can't do things with that, and page URL or location ID. So these things are just not useful for our model prediction and model performance, right? So we just got our clean data set as price, location, number of bathrooms and number of bedrooms and total area, right? So this is in the like square foot, right? But as we know, like we deal in marlas in Pakistan, so I just take care of that in my deployment part. And then I am just saying how many location or how many societies we have in our data set, and it's quite a lot, right? So I will just import these in my deployment with the help of Jinja templating for the right. And then I am just these and you can see we got the ISV data, those CSVs. So these cleaned data set will be like exported into that file, and then we are just doing some other like getting the idea about our data, and then what we are doing is like selecting our X and Y for the model feeding or model training, and then just importing some models and doing the train test split, and then I am just applying a model, right? So on the location, as we know, like we have very unique values, so we just created one hot encoder for that in our pipeline, right? And then I just applied the linear regression, and you can see the accuracy I'm getting was 69.9% or 70%, right? It is quite low, so we have to increase it. And with the lasso regression I got the same accuracy, right? Nothing changes here. And with the ridge regression I got almost same, right? So I just changed my algorithm, and like random forest regressor just worked like a magic on my data set, and it got me 86.7%, which was quite good enough for me, as we are doing a practice project only. We can obviously increase that by doing some other analysis on our data and like creating some more features with that, and but we are good with 86.7% for now. And then we are just making a pickle of our model as ISB house price predictor.pkl, and you can see I got the file as here. And let's go to the deployment part. And by the way guys, you can like contact me for this source code, and I will try to like arrange a Zoom explainer session if you want to do it, right? So yeah, so we are just like setting up our directory as static, because we want to show that image, this image, and then we are just loading our model. And then if we are getting the post request, which we will get from our index, right? And because index has a form, let me show you. Index has a form, where it is, yeah. So you can see this form will send a post request to display, and we are saying if you are getting a post request, so save the values in these variables, and then we are passing these values as the parameters, right, for our model. And then we are just predicting this result with the input, as we are like getting the location, the bathrooms, number of bathroom, bedroom, and marla entered by user. And for the marla part, I just like multiplied the marla, one marla, by 273 to get in the square foot, because in our original data set it was in square foot, so we have to take care of that. And you can see like we have to multiply it by 272.3. so we just I just multiplied it 273, right? And then we are just uh, limiting the our float value to up to 2 decimal place. And on the display we are just showing our predicted price as this price, and the marla entered by user, the location, the bedroom entered by user, and the bathrooms entered by user, right? So this was it guys for today, and I hope you like the project. And if you like interested in the source code, or maybe you want to show it somewhere, or wanna arrange a Zoom explainer session for this part, I can obviously do that. You can contact me on this WhatsApp, or maybe mail me at this Gmail, and visit my website. So thank you. Hi guys, it's me UBprogrammer, and today I am back with another project, which is image Cartoonifier. So let's just start our app and see how we can run our app, right? And this is a Flask app for our project, and image Cartoonifier app is live, right? And you can see as the project description says, upload an image and this website will try to convert it into a cartoon with the help of machine learning and OpenCV. And in particular we are using an algorithm, k-means clustering, for machine learning part, right? So let's just give it some input and make, yeah, okay. So let's give the picture of Imran Khan into the app, and you can see it is processing the OpenCV, and machine learning part is being done, and we will see the results in a bit, right? Yeah, so we got the results, and you can see the cartoon image look like this, right? It is like it can be better, of course. Like when I will be discussing about code, you can change the parameters, but for the sake of the uploading it to Flask and like displaying it, we are good enough for now. Let's do one more with the Mr. Modi, and let's see how we are getting the results. Okay, it is processing, and you got the results. This was the original image and the cartoon image. Let's do one thing guys, let's just download an image of Trump. Which one? Maybe this one. And let's just download it as JPG, or maybe PNG, or whatever you like, right? Name it as Trump, and save it, right? And let's do this on Trump. What happened with the file? Okay, Trump.jpg, and let's save it. Should be there, yeah. So this file was, I don't know, maybe corrupted or somehow. Okay, so let's do it on crump image and see how we can get the results. So it depends on lightning also, the lightning effect on your image, the original image. It can like vary from image to image, right? And okay, yeah, so we got the result something like that, but you can see his coat and tie are like Cartoonifier, right? But the face is not original or somehow not perfect, right? But yeah, for the sake of project we are fine with that. Let's just discuss the code. And yeah, let's see our notebook first. So we are using OpenCV and NumPy, of course, for mathematical arrangements to the images. And we are using machine learning part with the help of OpenCV, right? So here I have like declared a function of making clusters, right? So it will use k-mean clustering algorithm of machine learning and access is through the OpenCV, right? So we are not like importing a library from sklearn or something like that, but we are using machine learning from within the OpenCV. Yeah, so let's just, yeah, this was the code for function for detect the edges, and this was the function for making clusters. And let's discuss what a cluster is, right? So whenever you like work with the k-means clustering, it always makes some clusters according to your choice. So we are just randomizing this number of clusters, like this coat will be one cluster and this face will be one cluster, the tie will be of one cluster, and this will be like recognized or arranged by k-means clustering automatically, right? Because we have randomized this part, right? You can see from here random centers. So the centroid points are randomized, and we are getting results as based on machine learning algorithm, right? We are not doing this manually. Okay, and let's discuss the flask app. So we are just getting the file and saving it into our static folder and renaming it, then giving it to our OpenCV pipeline, and then just writing it again as cartoon.jpg, and then we are displaying it into our templates, right? So that was it, guys, for today. I hope you like the concept and video, and you can always like contact me on this WhatsApp or maybe mail me at this Gmail if you want to display the session or maybe want the source code of the projects and other projects like that, and I will respond you as soon as possible. Thanks for watching the video.